Access control sounds simple when you say it out loud. Give people what they need to do their jobs, and nothing more. In real life, it feels messier. You inherit old groups, strange exceptions, cloud apps that appeared overnight, and pressure to just make it work. That is the world where the choice between role-based access control, RBAC, and attribute-based access control, ABAC, really matters. This narration is part of the Tuesday Insights feature from Bare Metal Cyber Magazine, and it is designed to help you think clearly about these models in the environments you work with every day. At a high level, both RBAC and ABAC are authorization models. They answer the question, who can do what under which conditions for your systems and data. RBAC organizes access around job functions and responsibilities, things like service desk analyst or HR specialist. ABAC organizes access around descriptive traits such as department, location, data classification, device posture, or time of day. Both live in the identity and policy layer of your stack, not deep inside the network packet path or the antivirus engine on an endpoint. It helps to clear away a few common misunderstandings. RBAC is more than just a pile of directory groups, and ABAC is not a magic label that automatically means zero trust. They are not products on their own, and they are not mutually exclusive. Many real environments quietly use both at the same time. You might see traditional application roles tied back to AD groups, while a cloud access policy engine evaluates attributes like country, device compliance, and data sensitivity for the same user. Thinking of them as two different ways of expressing the same idea rather than competing brands makes the whole topic easier to work with. In a typical RBAC flow, the steps are straightforward. A user signs in, the system figures out which roles that user belongs to, and those roles map to permissions, such as read, write, approve, or administer. When the application receives a request, it simply checks whether at least one of the user's roles includes the needed permission. If it does, the request is allowed. If not, it is denied. Most of the real work happens earlier, when you design roles and decide which people belong in each one, but the moment of decision inside the system is usually simple and fast. In an ABAC flow, the decision looks more like a small reasoning engine. The access request carries attributes about the user, the resource, the requested action, and the surrounding context. That could include the person's department, whether their device is managed, the sensitivity tag on the record, where they are connecting from, and even the current risk score from another tool. The policy engine evaluates these facts against rules, such as allow if department is finance, data is marked confidential, and the device is compliant. Instead of only looking up a role, it evaluates a small set of conditions about the current situation. Imagine a simple business application with a dashboard for customer data. Under a pure RBAC model, you might have roles like customer service agent, team lead, and administrator. Agents can view customer records, team leads can update them, and administrators can change configuration. Under an ABAC approach, you might still keep those ideas, but express them as conditions. Allow view if the user supports this region. Allow update if they own this account. Allow configuration changes only from managed devices during business hours. In both cases, you are answering the same question, but the second model has more room for context that changes over time. In everyday practice, RBAC shows up wherever groups of people do similar work for a long time. Support teams, finance analysts, human resources, and database administrators are classic examples. A practical early win for many organizations is to define a small, clear set of roles for these functions, document what each role can do, and then map those roles consistently across applications. When a new support engineer joins, you assign the support role once, and they get the right access in multiple tools, instead of creating 3 or 4 ad hoc groups for every system they touch. ABAC tends to appear where context really matters, or where roles alone would explode in number. Conditional access policies in cloud platforms are a familiar example. You may allow engineers to access a staging environment only from managed devices, or restrict access to sensitive data to people in a specific country during local business hours. You can do this without inventing a separate role called engineer on a managed laptop during the day shift. In data platforms, ABAC makes it possible to use the same analyst role but show different rows or columns depending on project tags, clearance levels, or privacy constraints. Most environments end up with some blend of both approaches. RBAC provides a stable backbone that describes who does what in the organization. ABAC adds the real-time guardrails that pay attention to risk, sensitivity, and context. You might grant a database analyst role through RBAC, but still require the right project attribute, the right device posture, and a low risk score before granting access to production tables. Thinking this way lets you decide which parts of your model should be stable over months and which parts can respond to changes that happen minute by minute. There are good reasons why RBAC has been so widely adopted. It is relatively easy to explain, and when roles are designed well, managers and auditors can look at a role name and understand why a person has the access they do. Many existing platforms already support it, which keeps costs and skills requirements within reach for smaller teams. For a large portion of internal applications, a well-structured RBAC model gives you most of the security and auditability you need, without requiring a new generation of tools or a complex rollout. RBAC starts to strain when you try to encode every nuance of real life into static roles. Roles multiply to cover special cases, temporary responsibilities, and one-off projects. People accumulate many roles over time, and nobody feels confident removing the old ones. At the same time, context-based needs like location, device health, or dynamic risk do not fit naturally into the model. You can bolt some of these ideas onto RBAC with extra checks, but the simplicity that made it attractive begins to erode, and the model becomes harder to reason about. ABAC addresses many of these limits by expressing policies in terms of attributes and conditions. It shines when you need fine-grained control over access to sensitive data, or when your workforce changes quickly. It can handle contractors, partners, and cross-tenant access without constantly inventing new rules. The price you pay is complexity. You need clean, reliable attributes for users, devices, and resources. You need tools that can consume those attributes. You need people who can design, test, and maintain policies in a safe and predictable way. And you need the ability to explain those policies in language that makes sense to owners and auditors. Failure modes look different for the two models, but they are easy to recognize. With RBAC, you often see slow drift into chaos. Roles are created for one custom need and never cleaned up. Role names stop matching the work people actually do. Users end up with long lists of overlapping roles, and emergency access granted to fix incidents never gets removed. When that happens, your real model is whoever has collected enough roles can do almost anything, which is not what you intended. With ABAC, the common failure is designing clever policies on top of messy data. If department values are inconsistent, device posture checks are flaky, or resource tags are missing, the policy engine either overgrants or blocks legitimate work. Another pitfall is concentrating all the complexity into a central policy engine without clear ownership, testing, or monitoring. When users and support teams cannot tell why a request was allowed or denied, trust in the model falls away, even if the engine is technically behaving as configured. Healthy signals are more encouraging. In a well-run RBAC model, you have a manageable number of roles, each tied clearly to a business function. Most people need only a few roles to do their jobs. Those roles are documented, reviewed regularly, and retired when they no longer make sense. In a healthy ABAC deployment, the sources of attributes are governed, policies are versioned and tested before rollout, and teams can tell a simple story about why a particular decision was made. Across both models, you see fewer emergency overrides, clearer audit trails, and less surprise when you compare what you think should happen to what actually does happen. At its heart, choosing between role-based access control, RBAC, and attribute-based access control, ABAC, is about picking a language for your access rules that your organization can actually live with. RBAC gives you structure and shared understanding tied to job functions. ABAC adds the nuance of context and risk for the moments when the same person should have different answers in different situations. Most teams discover that they do not have to pick a winner. They can use roles for stable duties and attributes for the signals that change from hour to hour. As you look at your own environment, notice where stable roles already serve you well and where context should change the answer. High-risk approvals, cross-company collaboration, and access to sensitive production data are good places to ask whether attributes should influence decisions. At the same time, check whether your identity data, tags, and device information are trustworthy enough to support richer policies. The goal is not to chase acronyms, but to move toward access decisions that are safer, easier to explain, and better aligned with how your teams actually work.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.